In previous we completed the arrays topic. In the arrays we discussed about the one-dimensional arrays and its applications, and the applications like searching, sortings. In searching we discussed about the linear search, and in sorting we discussed about the selection sort and bubble sort. This is about the one-dimensional array. In coming to the two-dimensional array, the two-dimensional array is mainly used for to represent the data in tabular formats, that means in rows and columns. The main application is the matrices, and in matrices we discussed about the matrix addition, matrix subtraction, matrix transpose and matrix multiplication. These are the topics in arrays. Coming to the arrays, the main disadvantage is the size of the array must be specified at the earlier stages only. If we want to change in later, it is not possible. Next, the second one is in array we can store the elements of homogeneous only. That means the same data type elements are stored. So these two are the disadvantages. To overcome the second disadvantage, that means to store the homogeneous elements, the next topic is structures. A structure is a collection of heterogeneous elements. The array definition is collection of homogeneous elements. The structure definition is collection of heterogeneous elements. That means in the arrays we can deal only with the same data type elements. In structures we can deal with the different data items. That means different. One is the integer, one is the float, and another is the character, in this manner. Okay. In structures, the structure syntax is struct space structure name and open curly brace and close curly brace. In between the open and curly braces we take it as structure elements. And take as structure elements, and it ends with the semicolon. This is the structure. Struct is the keyword which tells the compiler it is a structure. So structure name and structure elements and ends with the semicolon. Okay, this is the syntax of structure. Next, coming to the example. So here I am taking a structure for a student. For students, it will be like, so the syntax is first starts with the keyword struct and the structure name. For it is students, and then I am taking it as the name student. This is the structure name, and in between the curly braces we take the student elements. That means structure elements. So for every student there is a roll number, for every student there is some marks and average. Here the structure ends with a semicolon. Here the structure is a collection of elements of heterogeneous, that means different data. Here it is the integer, and it is float. So these are the two different data items we taken. This is entirely called a structure. Okay. So a simple program for structure. So hash include stdio.h hash include conio.h. Next we generally write int main, but the structure is always defined at outside of the main. That means outside of the main. Struct student int number, int marks, float, average. These are the structure elements and it is defined outside of the main. Then write main, int main. Okay. Here we define the variables for structure. Generally after the main function, then next to main we declare the variables. Here also we declare the variables of structure. Okay. So that variables are defined like struct, structure name, struct, structure name, space, variable. This is the string. First struct, then structure name, then variable. Like that. For this, struct, structure name is the student and variable is S1, and struct, structure name is the student and variable is 2. So S1, S2 we can take as in same line or different lines, whatever it may be. I am taking the data for 2 students. So first I enter the first student number and first student marks and first student average. For this we use either dot operator or arrow operator. Either dot operator or arrow operator. So first I am using dot operator. First S1 dot number equals to 100, S1 dot marks equals to 750, S1 dot average equals to 75. S1 dot average equals to student 75. That means the structure variable is S1. For S1 there are 3 columns. For S1 there is some number, for S1 there is some marks, and for S1 there is some average. So I entered for student the number, first student marks and first student average by using the dot operator. For the second student I will use the arrow operator. Next, S2 of num equals to 101, S2 of marks equals to 780, S2 of average equals to 78. Okay, only the change is dot or arrow. So by using the dot operator we can initialize the values, and the same we can use the dot operator, we can print the values. I am taking the input. Here I take the input for student 1 and student 2. For every student, this is the student structure. For the structure student S1. So for S1 all the elements are available. For structure student 2 all the elements are structure elements are available. Okay. So for S1 there is a number, for S2 marks, S2 average. By using dot operator we can initialize, or by using arrow operator we can initialize. After taking the values we can print the result. For printf the first S1 student details are printf S1 number is S1 dot num. Printf S1 marks are comma S1 dot marks. Printf S1 average is comma S1 dot avg. I printed the first student details. In similarly, I can print the second student details also. Printf the second student details are, I'm writing here, printf the S2 number is comma S2 dot number. Printf the S2 marks are S2 dot marks. Printf the S2 average is S2 dot avg. So I am taking the values for the first student, I take the values for second student, and I print the values of first student and I print the values of second student. Then this is the end. So return 0 and main close. This is the example program for structures. In the structures, first we write the header files, then write the structure, and the structure must ends with a semicolon. After that we can write the main. In the main we create the variables for the structure. So the variables are can be defined with the structure also. So these S1 and S2 will be taken here also, whatever it may be, no problem. Okay, this is the structure. For this structure, the total memory is for integer it occupies 2 bytes, this for a 2 bytes, and for average 4 bytes, total 8 bytes for one student. So here I am taking 2 students, 8 into 2, that is equals to, it takes 16 bytes of memory. Okay, this is the structure.